Hello everyone. Welcome to today's session. Today we are seeing encapsulation in object-oriented programming. So yesterday we saw what is object-oriented programming and what are classes and objects and what are attributes like underscore underscore init and self method. So we already saw what are 8 steps way to master object-oriented programming. From among those, we already seen what are classes and objects and attributes and methods, how to use them. So today we'll see what is encapsulation. So let's see what is the definition of encapsulation. Okay. So encapsulation is a concept of hiding internal details, internal logic, and exposing only the necessary parts of the data. Okay, so in Python, how encapsulation is implemented? It is implemented through 3 keywords. One is for one underscore and two underscores and at the rate property. So these three are the keywords that been used to implement the encapsulation in object oriented programming. So here is a simple syntax that you can see my class definition underscore underscore in it. So we already seen yesterday how this will automatically initialize the class when you define this, and self will personalize the data for everyone who calls this class that creates an object. So now here you can see when we are defining self dot underscore, we are making this attribute protected, and when we are saying under double underscore, when we are making this attribute private, so we are making very harder to access by the outside world. So how do protected and private data can be accessed? So to access this private data, we can define at the rate property to the method. So this method can directly access this private data. So that's what it means, that the outside class, means from the outside of the class, we should not be able to access private data, or we should not access private data. So that's not the right way. And from inside the class, we should be able to access the private data and calculate the logic internally. So what is the purpose of encapsulation? We can protect sensitive data and provide controlled access to attributes. Okay, let's look at real world analogy quickly. So imagine an ATM machine. So it has internal cache, verification logic. So all these are hidden from outside world. You only interact with the card slot and the button interface. So the internal code logic attributes that are hidden, that are called encapsulation logic. So that internally the machine works with that, and it has access through at the rate property. So that is how we can define an analogy with encapsulation. So there are 3 levels of access in object-oriented programming. So when you are working with object-oriented programming, when you are working with classes, you can access attributes in 3 ways. One is public access, second is protected, and third is private access. So what is public access? So when you say self.attribute, so this is a kind of public access. So anyone from outside of the class, once they define the object, they will be able to access this attribute. And the purpose is to make attributes methods accessible freely. So, like for example, use case expose information meant to be shared. So the information that is meant to be shared, we can make public access. Okay. So here's a sample program. So I have a class with bank account. So I have this initialization of my class with the attributes. Now I have an internal method inside my class show details. So even this method inside my class has access to my uh, details. So these are my public data, public attributes. So internal method inside the class also has access, and I can access from outside of the class as well. So I have created my class. So let me create an object. So when I say ACC is equal to bank account with the name and the balance, it will create an object. So when we call the method. So I'm calling a method that is inside my class. So that is I'm accessing these attributes from inside of the class. So it will print owner inside the class self dot owner. So whatever I pass here, sharp and the balance, it will show here. Now, if I want to access attributes from outside of the class, I can say ACC. So whatever the object I created dot the attribute name. So when I say this, this is kind of accessing the attribute from outside of the class. So when I define my attributes public, I'll be able to access those from inside of the class and outside of the class. So let's see what is protected. So another method, another way of accessing attributes we have is protected. So protected is like handle with care. So this data can be handled have to be handled with care. It can be accessed, but it has to be handled with care. So protected attribute should not be accessed outside the class, but Python allows it. So it's just a convention, not enforcement. For example, there are certain logic, certain data that can be accessed. For example, here you can see show balance. So the show balance, so we are saying uh, I'm able to access from inside of the class and outside of the class as well. But this is discouraged. So this is not the right way. So where is the place where I define my attribute as protected? Here is the place. So this it has just single underscore. Here you can see self dot balance. So this is the protected. Uh, this is what making our attribute protected. If I use underscore balance. So now there is another method of accessing the data that is private. So what is the syntax for that? When we say self dot double underscore attribute name, so it will allow, this is meant for to be accessed within the class only. So only inside the class this should be accessed. This is to enforce the strict control. That is, true encapsulation is where when you use private method, private attributes access within the class to calculate internal logic. So some of the use cases you can think of is underscore balance and the pin of the user, all those things. Okay. So private attributes are hidden using name mangling. You can't access them directly from outside of the class. So here I have a class with definition, initialization, and I have set the balance as private. Okay. It's a private attribute. How can I can say I have double underscore before the balance. So now if I want to access this private attribute, I need to access from within the class only. So this method is within the class. So what I say, I create my object and I call this method which is in the class. So I'll be able to access this method. So it will show my balance from inside the class. So if I try to access this private attribute from outside of the class, so when I write in this manner, it's kind of accessing from outside of the class. So when I try to do that, it will error. So attribute error, bank account object has no attribute underscore underscore balance. So that is how you will not be able to access uh, private methods outside of the class. If you really want to access at the private attributes outside of the class, you have to do a name manual. So you can say acc dot underscore class name double underscore balance. So if you write that, you will be able to access private attributes from outside of the class. But if you access in this manner, it will break the encapsulation. So the concept of encapsulation, where we hide the internal details of the logic, will not be able to achieve that. So this is not the right way, but Python allows it. It's not recommended to use it. So why underscore underscore balance is not the right way? So I have explained it here. You can quickly go through this analogy. So what is the right way to access private attributes? that has encapsulated access, that is using at the rate property. So this is the right way to access encapsulation. So what is at the rate property? We can use at the rate property to expose safe read-only view of attributes. Since my underscore underscore balance is a read-only is a private attribute, I would like to allow it to be read only to the outside world, and internally the internal functions, the internal methods can access it to update the balance or to add the balance. So that's what at the rate property is used for. So let's see a class is equal to bank account. So I have a definition underscore underscore init self, owner, and balance. So self dot owner. So I'm making this a public, and I'm making balance as a private attribute. Now, how internally class? So how the methods inside the class can access this underscore or a private method, private attribute? They can access it through at the rate property. So whatever the method that I'm writing here, balance dot return self dot underscore underscore balance, I need to write at the rate property at the top of it. So that means it will read this attribute in read only mode. So it will not allow. So this method will not modify the uh, balance. It will just read it in read only mode. So let me execute it here. So it's creating an object and safe access. So this method is encapsulation. So we are using true encapsulation to hide our internal details and read it only in read only mode so that others will not be able to modify it. Okay. So now let's add deposit and withdraw method to our class. So this is our deposit method and this is our withdraw method. So what we are saying, how we should not be able to modify the balance from outside of the class. Only these internal logics, they should be able to calculate deposits and withdrawals and should be able to modify internally. So I call my class, it creates an object. So I'll see what is the initial balance, and we are able to uh, deposit 500 and check the balance, withdraw 200 and check the balance. So when I run this program, so it says initial balance is 1000. So using internal method, that is deposit, this method is modifying my private attribute and giving me the result, and acc.withdraw. So this method internally, since this is in the class, this method is able to access that private attribute and able to modify from inside the class and prints me the result. Okay. So all the methods that we want to modify the private attributes, it should be within the class only. So in short, encapsulation is like binding data and methods and restricting access. So the access levels are the tools that implement encapsulation. So what are the access we have? Public, that allows free access, protected, soft protection. So it's allowable outside but not recommended. Private access, it uh, gives a strict and puts strict and hard protection on the attributes. Only internal logic can work with that private attributes. Outside world can just read that, they cannot modify it. Okay, so let's look at one more example about the ride sharing app. So in the ride sharing app, let's consider a class. We have data, trip ID, driver name, and fare, and it has internal methods like assign driver, calculate fare, and update status. So these are the methods should internally work with private data and update the details. So the outside world should not access that private logic, and they should not be able to modify that. So private data is hidden from the outside world. So that is called encapsulation. So let's see a sample program. So I have a class ride, and so I have I put an initialization. So along with my attributes, rider name, pickup location, drop location, and fare. So I'm making rider name as a public attribute that can be accessed by anybody, and protected attribute. So pickup location is a protected attribute, and uh, fare is a private attribute. Since this is insensitive, should not be accessed directly, because I I would calculate the logic internally once a user selects pickup and drop location and the type of the ride. So status we can make public because status is required to access publicly. So now, how should since my fare is private attribute, internal logic should be able to access the internal method within the class should be able to access that private attribute. So for that, I'll define at the rate property and def fare self return self dot underscore underscore fare. So this will define the private attribute is able to uh, is been accessed by the internal method within the class. So these are some of the methods that update the ride status safely and ride end status like self dot status. So this is here we are showing the fare amount, how much is the fare calculation, and here like a, uh, if anyone has a code like coupon code, so they can apply the code. So internal logic will check that code and apply the fare as minus 50 and a print discount applied or discount rejected. So this logic is hidden from the outside world, and we are allowing only a method inside the class should access this private attribute and should work with this attribute inside the class itself. Outside world should not directly access this um, attribute directly. So we should work with this method only, not with the attribute directly. So once I create my class program, I can create the object ride one is equal to ride of or name of the rider and pickup location, drop location, and fare. So this is what it will generate. Okay. So ride status. So it will show the ride status. So this is accessing public attributes. Uh, since this is a public attribute, it will show the right status. And we are accessing protected attribute. So right dot underscore pickup location. So we are able to access protected. And if you want to access the private attribute, we should be able to do it via property only at the rate property that is defined inside the class. So this says that whatever we are accessing here, right dot fare, we are just reading it in read only mode. So we have set up our class in such a way that we have encapsulated the fare logic in and made the attribute in private mode, and we are accessing through at the rate property only in read only mode. So if you try to access it directly from outside the class, so this is the method, it will error out with attribute error. So now ride flow, how it starts, ride one dot start ride. So like internally, we can call the methods from which are inside the class, and it will take all those. It will work with all three attributes: private, protected, and uh, public methods. Okay. So methods from inside the class should be able to work with all these three access methods. And methods, if you are trying to access from outside the class, only public and protected will work. Private will not allow because that is not intended way of encapsulation. Okay. So to quickly recap, what is encapsulation? Encapsulation is the concept of hiding internal details and exposing only necessary parts. It is implemented using naming convention underscore and double underscore and at the rate property. Okay, so this was about encapsulation. So here we have sample example. So this is one of the example we have. So it's a mini exercise. We are creating a student class and that stores underscore underscore scores. So this is a private attribute. So this will allow reading via at the rate property only. So here is a student class. So inside the student class, we have defined this, uh, initialize these self dot name and self dot underscore underscore score. So we have made this as a private attribute. So how do other methods inside the class itself access this private attribute? We have to define at the rate property. So then only we'll be able, these methods should, we will be able to access this private attribute. Then outside the class, we'll be able to just read those attributes. And these internal methods will be able to read and write those attributes also. Okay, so our final thoughts: encapsulation hides internal details and exposes our control access. At property is a Pythonic way to access private data, and without encapsulation, code becomes hard to maintain and error prone. Okay, so that's it for today. We'll meet in next session with another topic. Thank you. Until then, take care.